right, so what I did, I'm feeling in a much better space today than yesterday. So I was looking before the lesson started for some really nice exponential questions coming out of past grade 11 external exams. And I thought today I'll do it. There's even one where it brings a hyperbola, so we can do that. And from next week, even as we move forward, I will still help with revision for the test, for the cycle test, which is, as you know, nature of 1 up to identities, by exponents and equation. All right, start. The first example I have for you of okay. It says 2019, which this was the external grade 11 exam question from last year. Okay, which actually makes me almost predict what they might ask you this year. So watch this. All right. So if you want to just see what I do here, this is the question. They said the point A, which is 3 and 54, lies on f of x, which equals to 3 p minus 27. The first question, 7.1, because by the way, this was question 7. You would never have known that, but now you do. The first question said, determine the value of p. Okay, determine the value. Little letters are always in the equations. Okay, how many marks was that? 3 marks. All right. Now, let's do it. There's only one unknown, and you have a coordinate that lies on your graph. So, write your graph, y equals to 3x plus the p minus the 27. Because the point 3 and 54 lies on this function called f, as you know, I can sub the x value into the x, and I can substitute the y value into the y. And by doing that, lamb chops, I'm going to solve for p. All right, so I'm going to put 54 into the y, and I'm going to go there. Sorry, that's an equals, very messy equals. Let's try that again, equals. And then we've got our 3. Replace the x with 3, so it's 3 plus p, that even rhymes, and minus 27. So I think you can see it's going to be an exponential equation because the variable you are looking for, do you see everybody, lies in the exponent. So we're going to bring the 27 to this side, all right? So if we add 27, because it'll become positive, we can get 7, 8, 9, 10, 11, carry 1, 5, 6, 7, 81. All right? And that will be 3 to the 3 plus p. Now, 81 is 3, I think it's to the 4, but let me see if my memory is right. 3 to the exponent of 4. Sorry, let's try that again. 3. Okay, I think I found the button. 3 to the exponent of 4 is 81. Yeah. I can't see the buttons any longer on my Casio. They just not there. But I'm going to show you something interesting. My Casio broke there and there. Still works. But now you can see that I wasn't lying. You see, it's a AAA battery. And I'm glad it broke because it's very easy now to change my battery. I don't have to undo all those little screws. So anyways, 3 to the power of 4 is 81. And here the base 3 is to the exponent of 3 plus p. And remember, you have learned that if the bases are the same, then we drop the base and just equate the exponents. So 4 equals to 3 plus P. So P is going to be 4 minus 3, and that rhymes as well. 4 minus 3 is 1. Well, that doesn't rhyme. But now we found the equation. So if I may, f of x equals 3x. Now watch. If P is plus 1, all right, that's fine, because there is a plus there. So you would just keep it, and there's your minus 27. So now I've got the equation, but the actual question was solved for P. So how would they mark this? I'll tell you right now. 1 mark for subbing the y into the y, the x and the x. 1 mark for getting the bases the same, and 1 mark for your answer. So that is exactly where they're going to mark the 3 marks. Let's see, what else did they ask? Because that wasn't hard. Okay, question 7. I'm just going to move question 7. The next question, 7.2, they say determine the range. Okay, so determine the range of the graph F. Now remember the word range, that's the one that has the tail. So remember, this will be a 2-mark question. We're looking for the up, down. Now, if you think about it, it's gonna, if you look at that, without drawing a proper diagram, you are looking at your horizontal asymptote. Your horizontal asymptote is going to be right down there, y equals to minus 27. Not drawn in any way to scale. Then the exponential, look, the a, the value in front of the base, if it goes to 1. But the actual base is bigger than 1, so the airplane flies to the sun. So look, we don't quite know. They're going to maybe, I don't know if it's going to the origin, but I can just tell you whether it's like that or whether it's like that, or however, you can see that it is basically the range. Y must be anything greater, bigger than minus 27. You must never include an asymptote. Never. You won't get the mark. If you prefer the other notation, y is an element, but be careful. You've got to go from the smallest to the biggest. So minus 27 would be on the left. And if you don't choose a round bracket, you won't get that. Positive infinity is the highest, but again, you can never get to infinity. So how they normally, if it's 2 marks, mark these type of questions, they give a mark for the value. And they give a mark for the notation. Okay, so for example, let's say someone put a square bracket there, but everything else is right. But you put that would be 1 out of 2. Let's say you went and included the asymptote, you'd probably get 1 out of 2, all right? But guys, very often these days, when they ask for things like the range, it's just 1 mark, and it's normally right or wrong. Okay, so far this test from last year has been really easy, all right? I'm just looking, can I now erase this little bit, because we know P is 1. I'll even write it here, P equals to 1. Okay, so now let's just erase this. So that was 7.2, determine the range. Obviously, they're going to say, I left this out, of what? The graph F. That was a bit stupid of me, sorry. Of course, it's going to be the range of the graph. And how did I do it? I was just looking at my horizontal asymptote, and if the base is bigger than 1, the aeroplane flies towards the sun, as long as the A is positive. All right. Now they're going to ask me a reflection question, all right? So they say, for the last question, graph G. Now, angels, please take note that graph G is not visible. You can't see it, okay? So they're going to tell you, is obtained. Okay, I'm very interested to what they're going to say. by reflecting the graph F, that one, about the x-axis and then they said determine the coordinates of the y-intercept. So it's a double question. Determine the coordinates of the y-intercept. That means you don't have to give it as a coordinate. They're coordinates. You know, give the answers coordinates, but they want the y-intercept of the new graph of G. So I would predict this is at least 2, yeah, 2 or 3 was my prediction. I will show you how to do that. I just want to rub this off. Okay. Just going to rub that away as well. Correctly. There's my base. And we've got a short. I'll even put back the A was a ghost plus. See my ghost? Scary, invisible. You take any graph, and you reflect that graph about the x-axis. The rule says, there is a rule, if you reflect about the x-axis, push the sign of the y to the opposite side. All right, so if x-axis, then you reverse the sign of the y. So let's do that in order to get the equation of G. We need to get the equation of G. So if we're going to make y negative, everyone watch the board, minus in front of y. So we get now that equals there, right? Now watch carefully. We do not keep the minus here. We each term, which means there's going to be now a negative. So the graph G, take note, it's going to be y equals, it's going to have a negative positive, but the rest stays the same. And please, exponent does not change at all. And then that minus times there, 27. So if they had just said, what is the equation of G? I've given them that. But there's more. Coordinates of the y-intercepts of G. Okay, well that's easy because to get the y-intercept of any graph, we just let x be naught. So to get the y-intercept of the graph G, this is 7.3, and that rhymes. Okay, so to get the y-intercept, we're going to let x be naught. All right, so let's do it. So y equals minus 3, make x naught, but remember we know p is plus 1, and there is your plus 27. All right, so we had to take the equation of G, where we reflected it first about the x-axis. To do that, we made y negative, because that's the rule. And then you times it through. That's why these signs changed. And now we're going to just solve, and we're going to get y equals to minus 3 to the exponent of 1, and then plus 27. So at the end of the day, that is just 27 minus 3, which is 24. 5, 6, 6, yeah. So as a coordinate, lamb chops, x would be naught, and y would be 24. Now the 2-mark allocation must be 1 for getting the equation of G, and I personally would have given 1 mark for making y naught, because x naught, sorry, they normally do, and then 1 mark for the answer. So that was 2 marks, but I actually decided, I think that was worth 3 marks. Okay, so I'm going to put that down. That was from last year. Now, just forget, okay, blah, 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 blah. Sketch hyperbola, all right? So, I a hyperbola this year and ask us questions and possibly make us sketch the exponential function, unless they make me sketch a parabola. But, you know, if they made me sketch a hyperbola last year, the probability is we're sketching a different graph this year. And that's exactly what we're going to do next. In my next question, I just want to straighten my phone. All right. So, guys, I'm going to erase that. Let's look at another question of the exponential graph. But let's, hopefully, we have to draw it. Because I want to remind you how to draw it. I told you hyperbola are very easy graphs. The parabola, even though it's not hard to me, but there's a lot to the parabola. All right? You know, minimum, maxima, lengths, and blah. And if you don't know what I'm talking about, don't panic. I will revise it whenever we need to for the exams. Okay, the next question. So that question comes there. Here. Okay, what exam is this? Gauteng province. June. And 27. So some schools for the June exams write external exams. Sorry, I just couldn't remember how to spell Gauteng. Gauteng. Apologies. You know, I live here. I mean, that was inexcusable. At Greenside, if there hadn't been COVID, we would have said internal June, July exams, but you will be writing the external. Just hold on 1 second. There's someone at my door. All right. Sorry, that was just James. Okay. So what happened in this exam? Oh, I remember some of the algebra in this exam was hard. I'll even prove it to you by ending off with one of the algebra. But as far as the graph, it was question 7. Oh, look, 3 to the x minus 1. How? Another base that is 3. Okay, it just happens I like the number 3, but I wish it could have been different. But anyway, what they said was in this order, they said determine the x and y intercepts. Okay, now while I write this down, you can try and work out determine x and y intersects of h. Now they did not say as you do, but you can go x equals y equals. But if they say determine the intercepts, your answer's coordinates. Okay, how many marks is that? 3. Okay, guys, this is a lamb chop question, you know, like really easy. Okay, so we've got the x-intercept, we've got the y-intercept. You know, for the x-intercept, we let y be 0 for any graph. For the y-intercept, we let x be 0 for any graph. And let's have a look at the intercept. So we're looking at the x-intercept, we're going to make y 0. So you get 1 mark for making y 0. Well, I actually don't know where they're going to give the 3. Obviously 1 for the answer and 1 for the answer, but the other mark, I have no freaking idea where they're going to give it. But look here, maybe it's here actually. Because if you take this minus 1 to here, you get 1. So maybe you've got to know that you can change the 1 to 3 to the exponent of 0 to get the 1. So that we will get, therefore, x is naught. Okay? Now, it's quite interesting, but I've noticed from experience with the exponential, if it's cutting the x-axis at naught, you often find it's cutting the y-axis at naught. Let's see if my hypothesis is true. Let y be naught. So we have, sorry, the y-intercept, let x be naught. So we got the naught, which is 1 minus 1. That's exactly what I said. Okay, I'll tell you where the marks are. 1, 2, there. That's the 3 marks. And now what do you think they're going to ask me? They're going to ask me to draw it. Now listen to how they word this. Sketch the graph of G on your answer sheet provided on page 7. Okay. Clearly indicate the points of intersection with the axes as well as the asymptote of the graph. Guys, 3 marks. This is 3 marks for absolute free. Oh, there's a word for that. I can't remember, it's an English word. You could tell me, but if I say it's 3 marks for free, I've done this with my son when I was homeschooling him. A homophone or something. Anyway, is anyone there?
Still here, ma'am. Still here.
Am I right? When a word has the same sound but a different meaning, is it a homophone?
Yes, ma'am.
So for 3 marks for free, is that a homophone?
No, ma'am, that's just a rhyme.
Oh. That's why I teach maths. All right, it just rhymed. That's all it was. So forget what I just said. I do not teach English anymore. All right, guys, it's cutting the x and the y-intercept at the origin. So I think, I don't know about you, that's a very important coordinate. The horizontal asymptote is going to be parallel to your x-axis. It must be, and it must be labeled, right? Except for label it correctly. It's y equals to minus 1. Okay? Y equals to minus 1. That is my horizontal asymptote. There, the A is positive. The base is being the one, airplane's flying to the sun. And I think you can see it's approaching, it's going through the origin, and voila. Now, in this example, just label it. I don't think I have to give another coordinate because 1 for the asymptote, 1 for the intercept with x and y axis because it's the same, and 1 for the shape. But you know I'm a bit OCD. I've always told you I'm a bit OCD. So I like to give another coordinate. So just make x 1. Do you agree? Look at your ancient notation. So if you make x 1, you're going to get the y value of that coordinate, which would be positive 2. So when x is 1, y is 2. When x is 1, y is 2. So I am just so used to, as a matric teacher, always showing minimum 2 coordinates on any graph. And I've said this before, if the x and y intercept are going to the origin, I personally would put in another point. But I don't think you would have been penalized in that question. What comes next? Okay, they want the range of h. Oh my word, okay? We've done this how many times? So this is 5 point. Okay, 5.1 was that. 5.2, sorry, was sketch. Okay, which is now done. Oh, if I get a magnifying glass, there's a chance that my arrowhead touched that line. So luckily I did this in a pencil where I can erase it. Because if there's one thing I hate in life, it's hypocrisy. So now, definitely not touching, I will get full marks. Okay, let's go to 5.3. They want the range. Do you understand? It's got to be any value bigger than the horizontal asymptote. You can see that, and we mustn't include it. So I'm just going to give one notation, the range. I'm just going to go y must be greater than minus 1. Okay, I'm not even going to put it in the other notation. 5.4. Oh, this I like, okay? If we have a new graph, P of X, and P of X equals to H of X plus 2. Oh, isn't that so exciting? Now, there's two things you could ask here. I'm going to ask you, write equation. They didn't actually ask this, but I'm going to do it. Of P, right? Now, you've got to know, we did this when we did the parabola, that if it's H and then a bracket and then X plus or minus a number, you horizontal shifting. All right, we're moving the graph to the left or to the right. It's horizontal. Let's try and spell that right. Okay, horizontal shifting. But I've told you this shifting. Yes, what's happened to my spelling? I've told you you've got to be so careful, because if that is a plus, it's actually going to the left. If that had been a minus, it's going to the right. I've always warned you, be very wary of the horizontal shifting. So the graph P, what shall we do this? P of X. So guess what? If you look at the original graph, look carefully. The base there is 3. We have X. Now remember, if you're moving it 2 to the left, we would also put plus 2 there. Because I taught you yesterday, that means we would be moving the graph 2 units to the left. That is where the horizontal shifting, and voila. Okay, but they didn't actually ask that question. You know what they did ask? They said, what is the x-intercept of P? Now, you don't even have to freaking do the long thing, because look, if this is the graph and you move it 2 units to the left and x is 0, poof, poof, I think you could see your x-intercept is going to be minus 2 and 0. That was actually the question that they asked. They could have asked us the equation of P. Right, now listen, I'm going to abandon the rest of this question. Questions. An exponential function with a fraction. We've done too many where the base is a whole number. So can I erase the board? Just or no?
Yes, ma'am.
Thank you. Do you understand, guys? Okay, okay, don't all talk at once. Okay, I'm going to make this one up. H of X equals 2. Okay, let's keep it for now. We're going to go half to the X like that. And we're going to go minus, let's say, 4. I hope I didn't do this one. Did I do this one? Yes. Wait a minute. Wait a minute. Let's make this plus 1. Do you see this is now grade 11? Are you all happy, yes or no or not? Okay, I assume yes.
Happy.
Happy. I'm so glad. You know what, Tanaka, you're always happy. All right. If they want, I'm making this up. What is the equation of the asymptote? Who could give me the answer? What is the equation of the asymptote? Anyone?
Y greater to
No, not that number. What's that number?
4.
Negative 4. So your asymptote, remember, is always y equals to whatever the q is. All right, just remember that. Okay, the next question. Yes.
You have 10 minutes left.
Thank you, darling. Now let's get the x-intercept. How do I get the x-intercept, everybody? I let what? Y be 0. So if I let y be 0, I have a half, and I've got the x plus 1 minus 4. Bring the minus 4 over so it becomes plus. Watch this clever trick. I'm going to take this 2 to the numerator, but it has a positive exponent. Understand that's the same to the minus 1. You should understand what I did there. I brought the 2. There's a ghost 1 with the, but then I had to change. I'm doing that break to 2 squared. And this is how I'm going to get my bases the same. Distribute. So you're going to have a minus x and a minus 1 times 1 is 1. So x minus 1. So let the exponent equal, bring this across. X-intercept is -3. Okay, as a coordinate, negative. Let's say they asked, what is the y-intercept? All right, you get exponent. So y would equal to half. You make x naught, so it's naught plus 1. 4. So a half to the exponent of 1 half. And a half minus 4 means it's minus the coordinate. That would be my y-intercept graph. Okay, and then I'm going to do the draw it. Have you noticed that I'm enthusiastic about graphs? Answer that? Okay, I'll do the asymptote in a different -4, but please, you guys, never. I am just using red. I can. This is the y equals -4 line. Now look, the a, but the base is a common fraction. So remember, to the ground and kill it. So no, it's going to come down, right? Because that is what I, which like 2 or 3, then it goes towards the sun. So you're going to see that it's cutting the x-axis at -3, which is here. So -3 naught. And it's cutting the y-intercept at -3.5. Naught there and -3.5, because that is -4. So I think what you can see, it's going to go asymptote and up. And I don't think I've come parallel. I certainly haven't touched it. And 1 mark, 1 mark, and 1 mark for shape. Are you with me? Now let's say the last question. They say,
Ma'am, in this graph, would they ask you to determine the reflection?
Yeah, I was going to do a reflection. Which one would you like me to do? Reflect about what? Should I reflect it about the
Reflection of the graph, y is equal -4.
Let's reflect this graph about its asymptote. I've seen that before. Okay, now I just have to think, because I don't want to get, I don't know why I wrote the question where I need to draw it. Okay, so let's say, Tanaka, we're going to, the last question is reflect the original graph, which is 8, about its asymptote. Not the x-axis, not the y-axis, about its asymptote. All right? Now, I think you can see, now watch, it's easy to get the shape. You can easily see it's going to do that. All right, so you get 1 mark, that's very easy. If I put ink there and I fold my page on the y equals -4, you can see I'm going to get that shape. But now how do we get the new y-intercept? Now watch. Do you agree, if you think about it, I don't know what color this is, let me guess, black. Okay, I want any color that's not black. So let's do blue. I want blue, blue, blue. Where are you? Oh, okay, I'll use this color. Brown. Do you agree? Now look here. We have gone vertically from naught down to -3.5. Now theoretically, even though my diagram's a little bit, let's just draw it again. That spacing there should actually be the same spacing there. All right, but I just want to draw it. So I think I just drew it really badly again. I want to try that one more time. Sorry. I'll get it this time. Look, it's going to go towards and down. Okay. Now, if from there to there was -3.5, and then that little space there is a half, then that little space there would be a half, and then we've got to go down by 3.5. So if I am not mistaken, and you can correct me, I'm going to say that is 0 and -4. That is what I would say the graph is. Who would agree with me? I'm just looking here. Look, we've gone 3.5 there, and then to get to -4, another half. So it's got to have the y-intercept. There's your half, and then there's your 3.5. So my y-intercept for symmetry would be at 0 -4. Who agrees with me? Someone?
Yes, ma'am.
Okay.
Also,
Now listen.
2 minutes.
I have 2 minutes. Yeah, that's why I'm going to use those 2 minutes to tell you how much I love you all. So who's coming back on Monday? The girls. But I'm going to speak to Nabil this weekend and see which days, I just got to look at my timetable, that he can video me. And what I think I'm going to do is I'm going to use this week to revise what's in the cycle test. And I feel I can do that because we've actually done a lot on Zoom. And if you go back, I've actually covered all your functions on Zoom. And that is a huge section. So 1 week of revision for your cycle tests. I think they're only something like 5 teaching weeks left, and then it's the exams or something crazy. But don't panic about that. I'll just let you know your mark. I don't know, you're going to get a mark based on, it's going to be 1, the cycle test. So you really want to do well, and we have to give 1 class test. Now, obviously, because I'm seeing you weekly, the class test would be different values, not the same. But I haven't worked out yet what the class test is going to be. But to get your term mark, okay, not your final mark, your term mark, it's going to be your cycle test, and it's going to be 1 class test. All right? So lamb chops, I love you lots. The class test would probably be more on the circles and maybe functions, because that's what I've been teaching for the last 2 weeks. I've been finishing the circle geometry, and I've been doing functions. So I'm not saying that's 100% fact. It might differ from class to class, but that's what I'm probably going to do. But in the meantime, please study hard for your first cycle, especially the girls. You're writing it on Friday. Nature, simplifying exponents, exponentially, trigonometry, Pythagoras function, those questions like